Remember, weather, depends on air temperature, depends on wind, right? Depends on humidity, depends on clouds, depends on precipitation. So precipitation is water in the clouds. If there's too much water vapor trapped in the clouds, they get heavy. Can't be suspended anymore. Woo! And they're gonna drop. Gravity is gonna take over. They're gonna fall down in the form of precipitation. And there's types of precipitation, such as rain, snow, hail, frozen rain, just like sleet. You have ice pellets, snow. So these are forms of precipitation. So precipitation happens when the clouds can no longer hold on to those water droplets or ice crystals that are suspended in the cloud. They get heavy and gravity is going to take over. If we're looking at weather patterns, really we're looking at masses of air. Remember, air has mass. Air is matter, has mass, takes up space. So, air masses are large bodies of air. That's what they are. Air masses, large bodies of air. These air masses move due to the temperature differences in the air masses. The weather of the air mass depends on where it was formed. The air mass was created from warm water. The air is going to be warm and humid air. So the type of weather in the air mass depends on where it was formed. Cold air and warm air don't mix because they're different densities. Cold air is more dense than warm or hot air. So the hot air is going to go upward. All right, warm air rises, and the cold air is going to go downward. And oftentimes when you've got a cold air mass meeting a warm air mass, that boundary creates weather patterns, like it creates thunderstorms. Fronts mean really a change in the weather. So a cold front is you're changing from warm air to cold air. Warm front, you're going from cold air to warm air. Fronts are indicated or shown on weather maps. So you guys are going to be reading weather maps, you're going to interpret weather maps, you're going to do a little weather forecast. But we have to know what goes on the map. So we indicate fronts in a certain way on a weather map. On a weather map, a cold front looks like this. We have cold air, warm air. The boundary is the line between them. This is the front. So this is where we're going to have a weather change in the weather. Now, the shaded in triangles here, these are pointed at the direction the air is moving. So it's cold air on this side, warm air. Here's the cold air is coming in to replace the warm air. Warm front is indicated like this. So we have, this is the boundary between the warm air mass, the cold air mass. We're going this direction. So a warm front is when the cold air is replaced by warm air. And when you have a warm front, oftentimes it is accompanied by rain, so rainfall. We have what is called an occluded front. So this is when we have cold air and warm air coming in. The cold air is moving faster though. So it moves faster, it pushes the warm air up. This cold air is coming in, or we have warm air coming in, but this cold air and warm air, they come in, the cold air is moving faster, so it pushes the warm air up, the warm front up, and that is what's called an occluded front. And this is when during this time, it usually produces a lot of rain. And the last type of front is called a stationary front. So just like it says, it's not moving. Stationary, stays the same place. If it moves, it's not a stationary front anymore. So here we have this is what it would look like in a weather map. So here, cold air on this side, warm air here. This is the boundary. And remember the cold air we indicate with the shaded triangles. So the cold air is going this direction. The warm air we indicate with the shaded semicircles is going that way. They stay in the same place and balance each other, so it's balanced forces, you could say. It's called a stationary front. If the force from the cold air is stronger than the force of the warm air, then it's no longer a stationary front, it would be a cold front. So now let's look at severe weather. There are really 3 severe weather patterns we're going to be talking about. Those include thunderstorms, and last time we had thunderstorms, we had lightning, dry lightning they called it, but there was no rain. So thunderstorms, tornadoes, and hurricanes. Thunderstorms are really created when warm, moist air rises up fast. So warm air shoots up. Warm, moist air rising up fast. High speed. And when it goes up, it cools. So as it's going up, it cools off. So when it's going fast updraft of warm, moist air shooting up in the atmosphere, fast, cools off, creates an electric charge that forms on the air molecules. So these air molecules now are charged, and it has a positive charge on the top of the cloud and a negative charge on the bottom of the cloud. So there's a difference in charges in the actual cloud itself. So in the cloud itself, it's charged. There's charges. The top part, positive, the lower part is negative. And the storm cloud induces a positive charge on the land below it. So right below, it induces a positive charge on the land. Positive, negative charges in the cloud itself, they rush toward each other, and that creates a bolt of lightning. So lightning is the movement of these electrical charges. It's the movement of the electrons. And remember, if you think of the states of matter we talked about, remember we talked about plasma, ionized gas. This is what has happened now. So lightning is an example of plasma. The gas, which is that air, right? The vapor, the air, has become charged. It's moved fast, it's heated up. Remember, plasma, it's got to get hot. When the lightning strikes, that generates a lot of heat, and it causes an expansion of the air around it. And that is the thunder you hear. So light travels faster than sound. So that's why when you see lightning, you see it and you hear it later, because it really happens at the same time, but we don't hear it at the same time we see it, because the sound doesn't travel as fast as light. It takes longer for the sound to get to us than the light. The air around the lightning expands. It creates like a sonic boom. Really, thunder is just the sound of air expanding. That air is expanding fast. That's the thunder we hear.